Continuing our lecture for chapter 14. Again, this is a very long chapter. A lot of content is covered here. This is going to be broken into 3 parts. This lecture is part 2. The effect of an exception. The throwing method finishes prematurely. No return value is returned. Control does not return to the client's point of call, so the client cannot carry on regardless. A client may catch an exception. So you have what's called the try-catch block. The throw, when that happens, inside the try-catch block, it says something happens, goes down to the catch and continues. All code from there does not happen. Things that tend to be problems are when you have files open, databases open, connections open, try-catch. It doesn't properly close those because you put them in the wrong place. You eventually run out of resources and your overall application crashes irrecoverably. Be careful about that. Coding it the right way makes a huge difference. Unchecked exception. Use of these is unchecked by the compiler, cause the program to termination if not caught. In other words, if something happens and you don't have a catch for it, the overall application will crash and cease execution. This is something that's always the case, and so just be aware of it. Argument checking. Public contact details, get details, string, key, if blah, blah, blah. This is going to throw, so if it's a null, it's going to throw an illegal argument exception. If the length is equal to 0, it's going to throw an illegal argument exception. Otherwise, you're going to allow it to continue through. Okay? There's more information that's not included in this code example that we'll go through a little bit later, but just right now we're only focusing on this part to help you understand. So an illegal argument exception is what's getting thrown in these 2 cases because what they passed in did not match. Okay? Preventing object creation. So more code up above, we're checking the values. If there's nulls that are set in, we're creating them to be empty strings, making our life a little easier. This is getting rid of the extra spaces. If the length is equal to 0, the phone length is equal to 0, then we go ahead and say either one of these must not be blank, but if the address is blank, we're going to let it go through. So if somebody passes in all nulls, we caught it up here, but in our error handling down here, we're going to take it out. This is allowing us to have a single statement. You could theoretically check up here if you wanted to, but this is a cleaner implementation, a little easier to read, things like that. Checked exceptions are meant to be caught and responded to. The compiler ensures that their use is tightly controlled in both the server and the client objects. Used properly, failures may be recoverable. So in other words, with that blank thing that we just talked about up here, if you catch this in the calling code, you could have something come back and just say, hey, I was expecting good data to come through, and here's the message that we got. Fix it. And you tell the user to do a good job. Okay? Throws clause. Methods throwing a checked exception must include a throws clause. So here, if we're throwing an IO exception, you have to tell the compiler that you're throwing it. Otherwise, it assumes that you didn't mean to do that, and now you've got things not aligning. The try. Clients catching an exception must protect the call with a try statement. So you have try in here, exception, whatever this is, exception E, report and recover from the exception here. So up here, there could be a problem where they didn't include the value. Here, you send something to the screen, or you do some type of an action to try and recover it, and you go from there. Again, I'm going to tell it a few times. This will be my second time. Open files and database connections are the most common things that happen up here. And when you end up down here, they don't get closed off, and you end up having all these extra resources open, which eventually causes your system to crash. Right now, these are things that we've not talked about, but think about it as you move forward in your Java career. That is something that is going to matter. All right, so try. In here, we've got an error occurred, exception thrown from here. It's going to transfer control down to here and continue to run. Try catch block is what this is called. Try, we're going to try to do the code here, and if an error occurs, we're going to catch it here. Try catch. That's why it says it like that. Alright, catching multiple exceptions. So you can try here. If I have an end of file exception, take this action. File not found, take this action. You can have as many catches as you want, as long as there's an actual implementation that matches it. Multi-catch. So, if it's this or this, then take this one action. So you can combine them together into one if you want to. Be careful, certainly doable, just be aware of it. The finally clause. This is what I was alluding to before about taking care of your stuff. If you try up here, you have a catch here, and then after everything is done, you finally do this. Here's where you would actually clean up your file handles, your database connections, and things like that. It's very important, and it's very helpful. The finally clause. A finally clause is executed even if a return statement is executed in the try or catch. I just said that. An uncaught or propagated exception still exists via the finally. Still exits via the finally clause. Defining new exceptions. Extend runtime exception for an unchecked or an exception for a checked exception. Okay? These two are very important. Pay attention to them. They do matter. If they're not clear to you at this point, go back through the book, read the section, send me an email if you're still not clear, and I'll help clarify it for you. But they are a difference. We did talk about it earlier in the presentation, and there is material in the book. Define new exceptions to give better diagnostic information. So in other words, you can create your own custom exceptions and use those to your advantage. Public class, no matching details exception, extends exception. More information about what we're doing, private string, no matching details exception. Notice they match. This is the constructor. Get the key, public toString. So the key is what got caught in the constructor when this occurs. No details matching key were found. Okay? This is fairly straightforward. There's nothing overly complicated. You can make this more complicated as you want, but it's pretty rare that people do that. This is very straightforward code. Stack Overflow is more samples. Google is more samples. The chapter is more samples. So if you need more detail, go through those. And as always, email me and I'll clarify. Assertions. Used for internal consistency checks. Object state, following mutation, things like that. Used during development and normally removed in production via a compile time option. They kind of get turned on or turned off. And Java has an assert statement. These are not used that often from my experience. Some shops will use them a ton, other shops won't use them at all. Java assert, so two forms are available. Assert some Boolean expression, assert a Boolean expression colon another expression. We'll go through more specifics here. The Boolean expression expresses something that should be true at this point. So in other words, right here, you know, the file handle should be attached to something, or some variable should be true right now, things like that. If this doesn't happen, then an assertion error is thrown if the expression evaluates. When might you use this? Debugging is probably the most common one. You're trying to figure something out, it's not working, you're going through the debugger, you did your manual code walkthroughs, nothing's working right, so you use an assert to try and find it. If you are familiar with C, you've probably bumped into this before. So, remove details, key null, throws an exception, key in use, blah, 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 comes down here. If not key in use, key is an assert. So if this doesn't evaluate to true, then it will throw an error. Here, it is consistent size, colon, throw this message. Okay? And that's what you're going to end up doing. So these are really good to use, and they're very helpful in debugging. They're very helpful in testing stuff. They're an addition to JUnit, they're an addition to other means, but these are really helpful when orchestrated properly. Guidelines for assertions. They are not an alternative to throwing exceptions. Remember how they said use them in development, not in production. They're used for internal checks, things that you need to do to make sure that your environment is okay. You should remove them from production code. Don't include normal functionality. Assert book.remove not equal to null. Don't do something like that, where it's actually trying to execute this and you're checking the results. These aren't the proper uses. Again, good things to use. Be smart about it. Error recovery. Clients should take note of an error notification, check the return values, don't ignore the exception per se. In other words, what you need to do is make sure that it's correct and that you got back an anticipated result or result that you coded for. Include code to attempt recovery is ideal. It usually requires a loop or something like that. So in other words, you have a do while, do a bunch of stuff at the end. If it didn't work successfully, go back to the top. If it did work successfully, allow it to drop through the loop. Here's a do loop. Okay, so if you go way back in our looping structures, we talked about for loops and while loops. Here is a do loop. The do loop is it always runs at least once. With a try-catch block, could be a really good implementation. So Boolean successful equal false, attempts equals 0. Attempts to save the file. If it wasn't to, it says it was unable to. We're going to go ahead and allow this to go through up to max attempts. And then, so if it is successful, drop out. Or if you've achieved the maximum attempts, it comes down here. If we weren't successful, produce an error. Okay? Max attempts would be defined somewhere up above. Take a moment to digest this. It is fairly straightforward. And it is a way that allows you to move through things. The one problem that you may run into is that this will happen at the speed of light in some systems. So whatever it is, it may rifle through 25 attempts in the matter of a second and never actually allow whatever is blocking this to get out. Sometimes you put pauses in here or other things. Again, for the sake of code, this is fine. It's helping you understand a possible case. All right, error avoidance. Clients can often use server query methods to avoid errors. More robust clients mean servers can be more trusting. Unchecked exceptions can be used. Simplifies client logic. May increase your coupling. Okay? Avoiding an exception. So basically check it before you do it. So if the key is in use or if this is in use, then do this. Otherwise, do an add. So in other words, if it exists, update it. Otherwise, add it. No sense in trying to do an add, finding out that it's already there, then doing an update. Check in advance. So to review what we've done so far, runtime errors arise for many reasons. An inappropriate client-server call, server unable to do a particular request, or there's some type of mistake in the code or other areas. Runtime errors often lead to program failure. Defensive programming anticipates errors in both the client and the server, meaning that you've caught them and you have handling set up. You potentially have looping in play to try and recover. Exceptions provide a reporting and recovery mechanism. With that, I'm going to go ahead and pause part 2 of this lecture and move on to part 3 because I want to make these digestible chunks. Hopefully you've got something out of this, and as always, send me an email if you have a question.